Good morning, good afternoon, and possibly good evening, depending on where you are. Welcome to this DFI webinar organized by the Sustainability Committee. My name is Gerald Verbeek. I'm the chair of the Sustainability Committee, and this is a webinar in a series of webinars organized by that committee to really convey the concept of sustainability. And today we're going to focus on geothermal engineering and geothermal energy. During the webinar, you will be muted, but it does not mean that you cannot communicate with us. At the bottom of your screen, you have the Q&A box. Please use that to ask your questions, because after the presentations, there will be about half an hour of Q&A where I hope to relay as many of your questions as possible to the speakers that we have today. But before we get started, let's talk a little bit about what sustainability is all about. Hopefully, nothing new, because it's something that probably is very familiar to all of you, and that's why you're here. Jamie, if you could just click on the next one. When you talk about sustainability, it's really trying to find the sweet spot. When you talk about the social aspects, the economic aspects, and the environmental aspects, where those three aspects come together for a project, that is what is a sustainable solution. Now, that's one way of approaching. If you go to the next slide, there are, of course, lots of different aspects that deal with sustainability. And what the United Nations have done a number of years ago is define 17 Sustainable Development Goals, SDGs, as they use them. And you see them here on the screen, ranging from the use of energy, use of resources, environmental issues, climate issues, but also equality. So there's a wide range of different topics that all fit into the issue of sustainability. If you go then to the next one, what is important to understand is that the whole concept of sustainability is something that, as a company, you really should start getting involved with. And in a previous webinar, 4 executives of American companies conveyed exactly that message. You can see in the next slide what those 4 executives that you see there, ranging from large engineering companies to small engineering companies to material or equipment manufacturers to contractors, they all came up with exactly the same concept here. And in the next slide, you see some of the statements that were made, because the fact is that most people will not take action unless there's a financial benefit to do so. And what you have to do, in the view of that panel, is to invent and introduce materials and techniques and solutions that put less carbon in the atmosphere. And then most of the time when you do that, when you come up with that, you will most likely come up with something that is less costly, and therefore the economic aspects and sustainability often go hand in hand. But the thing is, as you go to the next one, is that the main thing is that we need to put less carbon into the energy. And one way of doing that is by using geothermal energy. Geothermal energy is nothing more than taking the energy from the earth. It's a clean, renewable, and thus sustainable energy source that can be used for all kinds of purposes. And one of the things that we want to do today is really focus on it. In part because the Sustainability Committee has a work group that deals with geothermal energy. And if you are interested in that, please feel free to join the committee and that work group. But today we have 2 presentations. The first presentation will be by Hursit Ibuk from BAUER Spezialtiefbau GmbH in Germany. The second one will be by Tony Amos from Endurant, who is also the chair of that work group dealing with geothermal energy. But we'll get started with Hursit's presentation. The floor is all yours.
Dear Gerald, thank you very much for your introducing. Welcome everyone to my contribution today, titled Geothermal Energy and the Foundation Industry, Made for Each Other. Today, we are diving into the mutually beneficial relationship between geotechnical structures and sustainable energy solutions. In our session, we will explore how geotechnical elements, often perceived as temporary, can become integral component of a sustainable building concept. Especially, we will shine a spotlight on the innovative use of geothermal energy through structural elements like retaining walls, with a focus on the highly effective soil mixing technique, the so-called mixed-in-place technique. The advantages are substantial, encompassing reduction in carbon footprints and material usage, along with mitigating noise pollution and air contamination in the nearby surroundings. Particularly interesting is the positive impact of the mixed-in-place method on a building's energy balance, as its favorable heat transfer properties make it a preferred sustainable technique. By utilizing geothermal energy in this manner, even structures designed for temporary use can leave a lasting positive footprint on our environmental sustainability. So, buckle up for an informative journey as we explore how geothermal energy and the foundation industry are indeed made for each other. Let's uncover potential for a greener, more sustainable future through innovative construction practices. Enjoy the webinar and my contribution. Starting with the first chapter of my presentation, briefly on sustainability. As Gerald already stated, the United Nations have specified a basis to do so by determining the Sustainable Development Goals on their agenda on how to develop globally in a more sustainable way. Besides the way we live and use infrastructure or buildings, also the construction industry has to contribute actively to reaching sustainable goals. The 17 sustainable goals include ecological, economical, and social aspects. In our view, some goals has a particular relevance for geotechnical works. Considering these goals may help to develop sustainable products in construction. These are the following: good health and well-being, clean water, sanitation, industry, innovation, infrastructure, climate action. We recognize the importance of cooperation-based partnerships among construction stakeholders to achieve sustainable solutions. Through our observations, we have noted that the cheapest offer may not always represent the most suitable construction product. Additionally, there is a pressing need to integrate sustainable construction products into procurement systems. Our efforts are not only to reduce carbon footprint in the construction phase, but also to enable to reduce carbon footprint at the full life cycle of a construction or building. One option is to utilize geothermy. In Europe, there is our president of the European Commission demands for making Europe as the first climate neutral continent and define a roadmap how to achieve this. And it should become, this footprints should become smaller and smaller by time. And in 2050, the EU should become a climate neutral continent. BAUER achieved in the recent past certificates, the first in UK as the first specialized foundation contractor for sustainability. We have a so-called environmental product declaration on our soil mixing technique, mixed in place. First of such environmental declaration in our business. And in Germany, we have a German-based certification on showing our sustainable approach on our job sites as well. Now, Before diving into geothermal activation, it is important to understand the mixed-in-place technology, which is an advanced soil mixing technology. MIP or MIP is also used as an abbreviation for the mixed-in-place. Today, I'm referring to the mixed-in-place application for retaining walls for construction pits. However, mixed-in-place is also used for cut-off walls, foundations, float protection measurements, and so on. On the picture on the left, you can see an example of a retaining wall for a construction pit in Berlin. BAUER has been executed such kind of walls for about 3 decades. Mixed-in-place elements are constructed with a triple drilling auger, up and down movements during drilling process with contrary rotating of drilling augers ensures a homogeneity of soil cement mix. I will give you on one of the following slides more details. But before, I would like to mention the way how the retaining structure works in principle. Earth loads are transferred to the steel beams via arches, via an arching effect in this mixed-in-place elements. From there, the forces can be anchored back via grouted anchors. Now, second picture, job site in Linz in Austria. As promised, now I would like to explain how the mixing place technique, soil mixing technique works in principle. Okay, starting with the raw materials, namely the in situ soil, the cement and water. First, the cement and water are mixed in a suspension mixer to prepare the cement suspension. This suspension will be pumped through the hollow of a central auger down to the soil during the drilling process. After homogenizing a concrete-like material, the mixed-in-place material are created. It looks like concrete. The MIP technology is a unique technology that transports soil of different layers vertically and blends these layers together with the cement optimal. This is because of the counter-rotating augers. So you see in the video to explain the working principle. An advanced environmental sustainability is also given. The MIP leads to a comparatively low carbon footprint, needs less transport to and from a construction site, which means low local emissions such as noise and exhaust. And plus the possibility of geothermal activation, which is the second benefit of the MIP wall, besides the structural function as a retaining wall. Sorry. Now to the chapter to explain with the question, how can we determine the carbon footprint of geotechnical products in general, the CO2 global emission for the construction phase. And of course, I will give you an example and considering a comparison of different geotechnical methods. So you can download the carbon footprint can be calculated with the EFFC DFI carbon calculator. It's an Excel program to calculate carbon footprints for our geotechnical works. It can be downloaded from the DFI website. You can download it directly from here. And also a methodology and user guide is also given. Please download it and try how it works. This is a slide showing the first page of the calculation tool, but only to that you have an imagination how it looks like. Of course, there are also in the past the webinars given how to work with it. Also, these webinars are provided by the DFI and on their homepage. Please have a look, and it's very very good to learn it how it works. In principle, I would like to start only to say in this case the principal steps. On the left side, the input parameters, the activity data, such as quantity of materials used, transportation distances of materials and machines, machines itself and types of machines, construction time. These are the so-called activity data. And on the other side, we have emission data. That means emission data is the value of the carbon emissions of each activity. And this calculation process of the carbon calculator calculates the carbon footprint by multiplying each activity with their emission, and to calculate the global emission for the construction process of the structural element. And this is relevant for us. Now to the example for the retaining wall. This wall is, for example, 200 meters long, 20 meters depth, and is 16 centimeter. 2 feet 2 feet thickness, 0.6 meters. And on the left side, the one option is to do this retaining wall by a grabbed technique, diaphragm wall, where we excavate soil, and after the excavation, a classical concreting pouring stage, and inserting of an rebar cage on the left side. And on the right side, this, as I said, the mixed in place wall, the soil mixing method with inserted steel beams, as I have explained it with earlier, which works with this kind of arching effect. If we calculate both methods for the same wall, and we will get this kind of results. On the left side, a total comparison, the D wall and the mid wall. You see we have 1,150 tons of CO2. The footprint is that big, and the MIP wall is not that big. It's 790 tons for this mix in place technique. And you can see it is also a result of the calculation process of the carbon calculator, the emission sources, materials, energy, freight, and so on, where the carbon footprint comes from. In this case, the comparison shows that we have 30%, about 30% less carbon dioxide emissions, carbon footprint. In this, and if you calculate the difference, is 360 tons less carbon footprint. Okay, now maybe it's also important to understand what is 360 tons. And you can fly from Berlin to New York about 300 times in economy class. From New York to Los Angeles by car, 225 times, and so on. I have implemented 2 more comparisons. It's enormously only by changing the construction method, in my opinion. Now, the next chapter, after carbon footprint, the benefits on less traffic of this mixed in place technique, less noise emissions, less exhaust gases, example and results. The same example already here. Reduced traffic volume or congested streets, less neighborhood frustrations, decreased noise pollution, reduced exhaust emissions, resulting in better environmental and human health. This is why, because the mixed in place technique leads to 82% less trucks to and from job sites, from the job sites. These are tremendous advantages only by choosing the technology of constructing this kind of retaining wall. An alternative way to calculating the footprint can be done by the so-called EPD, the Environmental Product Declaration. It gives, the EPD gives clear information about how products affect the environment. Not only the CO2 is revealed there, but also there are other information on environmental effect, ozone depletion potential, and so on. What you see here, but is limited here, but the list is longer. But this should be remain okay. The next slide, you can find this EPD in our homepage. You can scan it here and download it. It's also free. Maybe you have a look and use it also. It's internationally acknowledged and made by a third party. It's third party verified and it's very transparent, and yeah, it's free to get it. The next chapter dealing with the use of geothermal energy. The use of geothermal energy is not a new idea, of course. However, the potential of temporary or permanent geotechnical elements for activation does not yet seem to be sufficiently exploited. In addition to private construction projects, geothermal heat can also be used for large projects such as the prestigious The Cycle project at Zurich in Swiss, an enormous building complex which used geothermal piles. With regards to geothermal activation, soil mixing methods are deemed an ideal execution method. Due to the beneficial intergranular contact from soil to the soil cement mix, heat is transferred without any discontinuity into the soil, into the geothermal activated element. This kind of job sites are done multiple times by BAUER. This is one in southern Germany, a construction pit where we have activated the MIP wall excavation pit, and in addition we have activated as well the bottom slab. I will explain it later in addition. But before, in principle, how the activation works with the building. In winter, the geothermal activation helps to heat the building. The soil and the MIP wall works as a storage facility. That means geothermal energy is used for heating. The storage will reduce its capacity during winter period. In summer, the geothermal activation helps to cool the building and stores excess energy in summer for making it usable for winter. The storage will increase its capacity during summer period. This is a regeneration process. The main benefit of soil mix materials such as MIP is the heat transfer between soil mix material. Of course, the system runs only if there are a balance between wintertime and summertime, ensuring same average temperature level over the years to keep the storage in winter and summertime on equal level. The temperature constellation of the soil can be predicted by calculating over several years. Here we can see such result on numerical simulation with finite element method. And already geothermal activation are made on drill shafts, support piles, diaphragm walls. The heat transfer is from the concrete wall to the soil is a defined heat transition. If you compare right side with mix in place method, with the soil mix material, a smooth heat transition is existent, And this kind of transition, this methodology are patented in USA and Europe as well for all soil mix processes by BAUER. Here, the tubes were attached on several steel beams, which are filled with a water glycol mixture for the geothermal heat transfer system. First, lifting the beams upwards with a carrier device, pushing the beams in the fresh mixed soil mixed material, as you see it on this picture. These pictures. The option is also given to connect the activated wall with the ground beneath with the slab, the bottom slab of foundation to activate also this structural member for the geothermal activation. In addition, at this job site in Germany, at Lake Constance, we have additionally activated the soil under the base slab, as I have explained it in the slide before. We have had connected the tubes of the beams with tube loops, as it is shown here. One picture a little bit closer. Here on the left side, a connection from the wall to the slab. On the right side, you see the loops on the slab before concreting the slab. It's under the slab, of course. So, a view in the utility room with the heating pump is shown here. On the left side. On this diagram, you see the number of days in a year, independent to the different degrees, the temperatures outside, and of course the warmer, where the most days are more than 0 degrees or 32 Fahrenheit, the majority of days, and there are a couple of days lower when 0 degrees or 32 Fahrenheit. And the BAUER energy wall works in this range. It works over 32 Fahrenheit to meet the demand of the building. The consumption of fossil energies ranges without a BAUER energy wall. The mixed activated the activated mixed in place wall is for the whole range of degrees before without this activation. And if after activation, you need only for a couple of days in the year the activation. This is the situation in southern Germany, but it can be transferred to other locations around the world, of course. Can be calculated. It's a sustainable solution, saves cost, makes more independent as well. Now, second picture from another job site. It looks like this. One impression in addition. And now, last chapter before my summary. The CO2, I will show you how to compensate the CO2 what we have used for in the construction phase with the geothermal activation in the usage phase. How can CO2 consumption at the beginning be offset through geothermal activation? For showing this, an example, the same example, 200-meter long wall, 20-meter depth, and 2 feet, 16 centimeter thickness. The reference system is a natural gas for heating and energy. Location is here in Munich, Germany. And the geothermal activation, we have considered 75% of the total MIP wall area. It's not the whole wall is activated in this case, and only 70% of the bottom slab is activated as well. Of course, the emissions after the construction phase lead to emissions, in our case, 790 tons CO2. We have an emission and it's also climate relevant, of course. And over the operating time in the following years, we have savings in terms of carbon emissions year per year because of the geothermal activation. We save a lot of energy year per year. And you will see if you add year per year the benefits on each other, you have a break-even point here in this case after 12 years operating time. In this case, each year we save 65 tons per year of carbon dioxide, and of course, then you can calculate 12 years to have and break even. I think now I can sum up my presentation. And it should be clear why geothermal energy and the foundation industry belong together and are made for each other. Geothermal energy and the foundation industry complement each other. I have emphasized the potential to reduce carbon footprints by choosing the construction method and by repurposing structural components. I have highlighted the advancements in geothermal activation in soil mixed materials and technologies like MIP, which lower emissions during the construction and enable greater geothermal energy utilization. Incorporating CO2 emissions and heat calculations into building planning is essential for maximizing renewable energy use. Additionally, I have mentioned strategies to offsetting CO2 emissions during construction and during with the usage phase by using the geothermal energy. Thank you very much for your attention.
Hursit, thank you very much for your presentation. And it's nice that you started off with an introduction on sustainability and then moved to geothermal. So it's really a good first presentation for this webinar. For the attendees, questions, please type them in the Q&A box. After the second presentation, we will have a Q&A with both presenters to address your questions. Second presentation is by Tony Amos. As I said, he is the chair of the Geothermal Energy work group within the Sustainability Committee. And he has been really pushing this concept of geothermal energy quite a bit. And he can give you some very good information about some projects that he's been involved with. And now that you've heard the introduction and the concept behind it from Hursit, it's a good thing to go deeper into this whole thing with Tony. Tony, the floor is yours.
Thank you, Gerald. And I would just say gute Arbeit to Hursit. A lot of messages there that I've certainly been trying to convey for the last 20 years. My background is in foundations, so I spent a lot of time with Skanska, Balfour Beatty in the past, and I kind of joined in the drive for geothermal and energy foundations specifically in around 2003-04. And I have to admit, it is one of the most frustrating things that I've ever been involved with, but it can be very, very rewarding. So I'm going to start off with a bit of the bad news. I'm just trying to, there we go. So the bad news, and whether you are a climate denier or not, CO2 levels have spiked incredibly over the last 60 years, and at some 100 times quicker than has been seen over the last many thousands of years, as you can see in this data. This is from Scripps Institute of Oceanography, and in the run-up just before this, I was thinking, oh, what was 2023? The figure in 2023 was 420 parts per million in terms of current dioxide. So you can see that we have a a significant issue, and driving down CO2 is a crucial part of everything that we do in the construction industry and in the way that we live, and as Gerald and Hursit have already outlined. In the US, one of the things that amaze me is the amount of money that is spent dealing with climate disasters. So this was a slide from the NOAA website, and in 2022 there was 18 weather climate disasters that each cost $1 billion in damages. And I thought, well, and again, I thought I'll just check whether the 2023 figures are right yet. And the 2023 figures showed that there was 28 weather events last year that were over $1 billion, and the total cost of all those dealing with all those weather events in the US alone was nearly $100 billion. $100 billion just to deal with these. And again, some people might say they're not climate disaster, it's just natural. But when you start to look at history, you can see that there is a definite increase in weather and climate change, weather and climate impacts. And like I said, in 2023, the recorded cost of all the kind of weather events was $93 billion. That's a phenomenal amount of money. And I'm interested now to understand whether there's a similar kind of table in Europe for this kind of information. But not only that, it's not only the cost, but there's also the impact on everything as well. Last year, there were nearly 500 deaths associated with climate change. So death and the financial costs are pretty phenomenal and quite concerning, and seem to be on an uphill trajectory. And I think one of the things that we are seeing is that some of the third world countries, the population is now growing significantly in those areas. And those areas tend to be areas where there's a greater demand. There's a greater demand to provide cooling as a means for improving productivity and increasing urbanization. We're seeing more and more air conditioning units hanging out of the side of windows, and that is putting an increasing burden onto the electrical grid, and a lot of grids, a lot of energy is generated from coal-fired power stations. That's right, and that is adding to CO2. But what we have seen over the last 10, 15, 20 years is this drive from that dirty molecular past to an increasingly electron future, which needs to include more solar PV, more wind turbines, nuclear for sure, hydropower, and a lot more battery storage. And one of the things about the US is that the Biden administration in December 2022 introduced a Inflation Reduction Act that had a massive impact on ground source heat pumps, to the effect that if you install a ground source heat pump system and you deliver 50% of the building's heating and cooling, you can get a tax credit on your geothermal system of up to 40% tax credit. If you hit that 50% mark, you then get, you can recover the tax credit, not only the geothermal system, but all the mechanical equipment for the distribution equipment that goes with it too. And that is a game changer. And some of the size of projects that I've been looking at, I'm thinking, how on earth can the US afford to provide that kind of tax credits for ground source heat pumps, geothermal heat pumps? And in November or December this year, December last year, there was this amazing report that came out from the US Department of Energy, which highlighted the benefits and the recognition of what geothermal heat pumps, the importance of geothermal heat pumps in decarbonizing certainly the US here. But some of these bullet points here, you can see that you know, if rather, and there's a, what we hear about is people talk about heat pumps, putting heat pumps into homes all over the place, and they are generally going to be air source heat pumps. And the trouble with air source heat pumps, they are 3 to 4 times less efficient than a ground source heat pump. And for the very reasons that the ground temperature, as Hursit said in his slides, could be on average, we found about 55 degrees Fahrenheit, even in the coldest day. So when you factor that into building a grid that's capable of dealing with this drive for electrification, if they pursued a ground source heat pump strategy, you can see that the reduction in demand would avoid as much as 24,500 miles of new grid transmission lines. You start to put some numbers to that. It's saving $300 billion through to 2050. CO2 emissions from that construction activity, again, I mean, some crazy numbers, but you start to see that the US and certainly the Biden administration has recognized the importance of ground source heat pumps, which is excellent news for us in the foundation business. So, and what I see, I've moved out of doing energy foundations altogether because I saw this in 2005 as a great solution. But what you realize is there's not just one geothermal solution for a project. So our approach would be to talk to a developer and say, okay, we need to understand what your heating and cooling loads are. Let's have a look around the site and what are the options for you? What makes the most economic sense? What's going to provide the best CO2 reduction? What's going to provide the lowest capex, but also importantly, the OPEX of a geothermal system? And what you see here is the multiple solutions that we have available to us as a geothermal ground source designer. And one of the best solutions, and again the carbon calculator, and the kind of numbers that Hursit showed on his slide, one of his slides, was using foundation. So he's got his technology, his soil mixing technology, and he's worked out what the carbon value of delivering that. If we went for a solution as if we were drilling purpose-made boreholes, for instance, you've got an added carbon impact on that solution. So you can see now that if the foundations are deep enough, energy foundations have a significant benefit in terms of low operational costs, lower install costs, and we've already said, you know, heat pumps are 4 to 5 more times energy efficient than a ground source heat pump, gas-fired boilers. These units will provide heating and cooling too, so you can save room in a plant room. And ultimately, a lot of cooling that we see is done by evaporating water on a roof. So again, a pretty important resource just being evaporated into the atmosphere, which is adding to global warming and also using what will become, I believe, a very valuable resource over time. So what is an energy foundation? And the way we approach, and I've always approached an energy foundation solution, is by asking the foundation contractor, okay, well, what is your reinforcement detail? How do I put a loop within your cage? I'm not looking to change anything about a foundation design in any shape or form, unless it's absolutely necessary. And so we're simply using the structural design of the pile to utilize it for that additional capability of delivering heating and cooling to a building. And in my 20 years, my frustrating 20 years of doing this, and I say frustrating because it takes a long time to persuade people to do this. And what I'm hoping is we need all the people on this webinar to start asking themselves, well, you know, what about this job? Can I put geothermal loops in what I'm doing on this particular project? And tackling the developers and saying, you know, have you thought about putting geothermal loops into these foundations here? over the 20 years I've been doing this, I've put geothermal loops in every type of foundation, slurry walls, diaphragm walls, CFA piles, even precast piles. About to do a trial up in Boston where we're going to attach a geothermal loop, 2 geothermal loops to a steel beam and drive it down to 160 feet. I'm pretty confident that we've already done some trials in New York with that system, and we've got a solution that works. But again, not only do we have a solution for each of the foundation technologies, it's a bit of a no-brainer to add geothermal loops to a solution. So this was a project that I was involved with. This is the Google HQ. They had about 6,000 piles on this project. I put a shout out to Malcolm Drilling, who did a phenomenal job. The productivity rates per rig here were something like 30 piles a day. Probably shouldn't be telling you that because there's probably some competitive advantage there. So, so what you see here is the geothermal loops are simply attached off of the critical path here. And then the piling contractor was allowed just to carry on as normal. And the other benefit of this particular project was that the ground conditions here were highly contaminated, and they were looking at a geothermal borehole solution anyway. So, and there was about 500 feet boreholes that were to be drilled. The problem was they were going to generate an enormous amount of contaminated spoil to be removed from site. They were also concerned that they were going to drag down contamination into lower aquifers. But of course, the foundation world has a solution for dealing with these kind of ground conditions called a displacement pile. And like I said, the Malcolm guys here were phenomenal and did, they were achieving over 30 piles per day per rig down to about 120 feet. Now, that's about 3,200 feet a day of geothermal loop. One drilling rig drilling a purpose drilled borehole would take 1 day to drill 500 feet and put a loop in. So you can see the immediate benefits of going an energy foundation solution on this particular project, not only from the lack of contamination that needed to be carted off site, but also the kind of the speed at which work was done. And there was no impact on the construction schedule here. Good coordination is paramount. And there's a little video clip of this bar going in with the geothermal loop down to 120 feet. And this one particular pile is obviously going to form this pile cap of 4 on the right-hand side ultimately. But it is all about making sure that you've got the early coordination with the various teams, not only the piling contractor, but before that with the consultants, both geotechnical, structural, and the mechanical team. So it's bringing lots of parties together, and then of course it's about getting it right first time when you go to a site, because once this is all concreted in, you're never going to see it again. So again, you need to take that into account when you design these systems. So what we see here is these 4 piles on the right-hand side here, all being connected together, which is, when they're added together, is the equivalent of a single borehole. And that's run back to a sub-manifold location. So if there is an issue later on, they can be isolated. So you can see there that was a very quick installation of a geothermal loop in one of the piles. Meanwhile, the piling rig's drilling the next pile. So it's like I said, it's a no-brainer of a solution, and it's not being used enough. And I mentioned my frustration and that we're not doing this often enough. I was fortunate that we now have an active project or building that's went live sort of probably 6 months ago. This was an office space, and the design here was to deliver 300 tons of cooling, 70 tons of peak heating. And what I liked about this particular building was it was all going to be radiant slab. and importantly, it was an all-electric building, so there was no gas boilers or anything like that. And the beauty of radiant slab heating and cooling is that you can deliver heating at a much lower temperature than you would normally to rooftop fan coil units and radiators. But one of the things that is so important with geothermal systems is understanding the heating and cooling load of a building every single hour of the year. Because what you need here is we want to design these systems to outlast the building. So it's important that we understand what happens every single hour of the year. And effectively, ultimately, what we're looking to do here is to deliver the heating, is to treat the ground like a battery. So what we take out in the winter and deliver heating to the building, we're going to cool the ground. We want to put that heat back in the summertime and deliver a lot of cooling and effectively recharge the battery. And I'm going to come back to that in a moment towards the end of the slides here. But on this Greenwich project, we had 63 120-foot deep piles, 26 and 32-inch caissons, large enough for us to put 3 geothermal loops into each pile. So each of those piles were connected, each of the loops in each of the piles were connected in series and run back to sort of 7 or 8 manifolds that you see here. And then each manifold is then run back to a main manifold where it all runs up to the roof and delivers the fluid to the heat pumps. Again, just coming back to that energy model and that the building heating and cooling load, this is the timeline of what we expect in the ground to the changing ground temperature over 240 months, 20 years. Ideally, and we have designed projects in central London for Crossrail that had 150-year design life. The important thing is that there's a monitoring system that's installed here into these systems that measures the performance, ground temperature, and has the ability that if this gradient on this temperature increase is too steep, you can adjust it, because you probably won't know there's a problem with the heat pumps or with the ground loop until 5 or 6 years time, by which time you may well have taken out too much heat or put too much heat back in the ground, and your heat pumps will just go into fault mode. But also the important thing is to work out, well, how much of the heating and cooling can the foundations deliver? And on this particular project, we were delivering it was over 30% of the building's cooling and about 40% of the building's heating. So we combine ground source heat pumps here with air source heat pumps in this particular solution, which makes for a great solution and makes for a great hybrid solution. We can use those air source heat pumps to help moderate that sort of gradient if necessary over time. And again, good coordination on this particular project. Absolutely no impact on the construction schedule. I think the only thing we needed from the piling contractor was on the spacer plates that you see in that middle photograph there. Half moon shapes were cut out so we could slot each of the loops in. Again, this is a little video clip of speeded up of the loops being installed. We were waiting for the piling contractor to more often than that. Well, I don't think they ever were waiting for us, basically. But again, you can see that very simple operation. It's just an added, you've got a welded blanket there just to make sure no sparks are going to damage the geo loops. And on the top right-hand picture here, we've got these little white sleeves. So where the pile is trimmed to, we add that additional protection to make sure the loops aren't going to be damaged from machines breaking the concrete down. And then more importantly is the QA/QC piece, and getting it right first time. Because like I said, if you have a leak at a later date, you ain't going to go back and repair it. So you've got to have it is important to make sure everything is tested, and every time you add another piece of loop to it, it's left under pressure. So yeah. Oops. Sorry. So so the next phase of the work was obviously the forming the actual pile caps and foundations. And again, what I would say here is if you've got a geothermal borehole solution that are being drilled to 500 feet, you've got to excavate trenches and you've got to run pipework back to a manifold. Here, and with an energy foundation project, we're just utilizing the structural members that are connecting all the piles up to the foundation slab. And what you see here is the piles being, top left, piles being trimmed down. And I have to admit that, you know, the kind of geo loops here were pretty bomb-proof from the abuse they were being given. I mean, this surplus loop was cut down eventually to, you see on the bottom left, those white sleeves. So the geo loops, so those white sleeves were removed, and then we were able to cut the loops down, do a flush test, pressure test, and then give the green light for the foundation contractor to fill to concrete the pile cap. And again, what you see here on the bottom right is pile cap constructed with a loops left under pressure, just to verify. When we come back to make the next connection, the first thing we look at is that the pressure's been maintained, so that we can then start to run all the geothermal loops back to what we would call a submanifold. And what you see here is the location. The little circle here is showing you where two submanifolds will be sited. So you can see the pictures of those manifolds in the top right picture. And then what we have is a reverse return that connects up all the submanifolds and runs back to the main manifold. And then the main manifold runs up to the equipment on the roof. And what we have here is the ground source heat pumps and air source heat pumps. And the beauty of this equipment is that depending on what we are telling it, it will operate in ground source heat pump mode or air source heat pump mode. So again, saving a lot of rooftop space and equipment. But in order to do that, there is a bit of monitoring that's required. And probably the most important piece of the equipment that is installed on these projects. Now, thanks to the New York State Energy Research Development Agency, NYSERDA, they helped fund putting in some strain gauges and temperature sensors into 3 piles on this particular project. Not necessary on every project, but we felt we did it on this particular project, so we got some long-term monitoring of the foundations, and to enable us to then, with our algorithms, control how much heat is coming out of the ground and how much is being added back into the ground. But more importantly, we are taking a measurement from air temperature, and we know what the ground temperature is, and we can do a simple calculation to work out what is the most energy efficient way of delivering heating and cooling, whatever the building's being demanded. So there will be parts of the year, and that tends to be around this time of the month. We call these shoulder seasons, where the temperature is very kind of is potentially going to be warmer than the ground or cooler than the ground, and we can work out what is the most electrically energy efficient way of delivering heating and cooling. And then that calculation, we then just send the signal to the heat pumps on the roof to operate in the most energy efficient mode. But the important thing here is that we then start to provide that long-term management and monitoring of the system, and we can start to treat the ground like a battery, like I've said, a thermal battery. So this was a screenshot from I think this was February this year. We pretty much delivered all of the building's heating here. Now, we did say when we designed this that we thought we were only going to deliver about 38% of the building's heating. And what we found actually is we've actually been able to deliver all the building's heating. Now, you can see at the top there, the outside air temperature is about 24.67 degrees Fahrenheit. Ground temperature in February was around 50. Leaving, going into the heat pumps was about 54.44. So when you do a coefficient of performance, so what you see here is if the air source heat pumps were delivering all the heating today, on this particular day, we would only get an efficiency of 2.9. So for every 1 unit of electricity that's produced, we're going to deliver 2.9 of heat. Whereas the ground source heat pump temperature, we were going to get 5.7 units of heat from that 1 kilowatt, that 1 unit of electrical energy. So again, you can quite clearly see the benefits of this. But the beauty and most important part of this is that what we don't want to, this enables us to manage that sort of gradient, temperature gradient of the ground over time. And this year, what we're doing is we're just monitoring and creating an actual energy model, a true model of what's happening in the building. And probably this time next year, we'll be sitting down around a table and working out, okay, how can we deliver more heating and more cooling? Can we? So what we want to be doing in the summertime, we want to deliver more cooling and bring this ground temperature under the building up to about 90 degrees Fahrenheit. So when we go into that winter season, we've got some really nice warm ground and we can deliver all the heating. And in doing so, what we're then doing is we're going to drive that temperature down to about probably about 40 degrees Fahrenheit in readiness for the summer season. So we can then start to make we're making the battery work hard here now. And the important thing is that long-term management of these systems to make sure that year on year, the ground isn't overheating or overcooling is so important with these types of systems. And just finally, like I said, it's frustrating that we aren't doing much more of the, putting geothermal loops into foundations. I was involved in putting a proposal together for JFK Airport that had over 5,000 piles, still driven piles with a nice hole that we could have just dropped a geoloop into very simply. And we could have delivered an enormous chunk of their heating and cooling solution. But the powers that be felt it was going to be too complicated. I think there was also some political reasons as well. But sadly, that's the kind of world we live in. But as we said, that bad news, those bad news stories, the climate changes, we drive us to lowered CO2. Hopefully, those times will change, and I believe they are changing. That's all from me. Thanks for listening, and back to you, Gerald.
Thanks, Tony, for a very interesting presentation. That shows the options, and just to chime in on what you were saying earlier about weather-related events. If you go to the news of the last 3 weeks or so, every night there are stories about tornadoes, tremendous amount of rain, major wind events throughout the country. So whether or not it is a climate change related issue or not, there are definitely weather related issues that are associated with the CO2 content. So anything that we can do to bring that CO2 content in the atmosphere down is only beneficial. I would like if Tony and Hursit can turn their webcams on so that we don't have to see now for the next half hour or so only the part, the slide that says that there's going to be Q&A. Couple of questions that came in. One of the questions, I could almost see it coming because it's always funny to see the audience, and of course we are engineers, most of us that are on this webinar. Tony, you mentioned a whole list of different types of foundations that you put the geothermal loops in, but you did not mention helical piles. And sure enough, somebody came with the question, well, what about helical piles? Any response to that? Is that possible as well?
Of course it is. I mean, generally a geothermal loop is 1.5 inches in diameter. There are smaller diameters. So it's all about trying to put a loop down the kind of central stem once the screw piles are in. Kind of screw piles don't tend to go particularly deep. That said, I was talking to the design team in the UK, the geothermal design team, and they have a house that is a passive house, which means it's got very low heating and cooling requirements, and it's got lots of insulation. And they had 20 piles that were about 12 meters deep. And by placing a geothermal loop in each of those piles, they were able to deliver all the heating and cooling to that building. So, yeah, I mean, if the diameter is the right, that central stem is the right size, then absolutely. And we could put smaller loops in, but the smaller the loop, probably not as effective. But I'd love to give it a go.
But basically, the message is that whatever type of foundation that you have, the options are there for geothermal energy. And that's something that's hopefully after this webinar, that message is loud and clear. The other thing, of course, that comes up and with people now from Germany, here in the States, although Tony, of course, is originally from the UK. Can both of you say something about the standards that are available? Because obviously, when you want to introduce a geothermal option, people will wonder, okay, what kind of standards are you going to follow? Building authorities want to know that. Hursit, starting with you, how is it in Germany and in other European countries?
Yeah, the authorities ask for limiting the temperature in the batteries, the thermal temperature in soil, not below 0 degrees, 32 Fahrenheit, and not more than 30 degrees to a certain kind of range of temperature ranges are required, and it's to be fit and monitored, of course. Yeah.
Okay. Just for the American audience, 30 degrees C is 86 degrees Fahrenheit.
Yeah, sorry, yes.
Yeah, no problems. Tony, I know you're heavily involved in guidance and standardization documents. Can you say something about that?
Sure, absolutely. So in the UK, there's a really nice little standard, Ground Source Heat Pump Association, and I think they call it the Thermal Pile standard. It's a kind of a best practice document. There is a small fee for it. I pulled that together with a group of similar kind of ground loop designers, foundation contractors in probably 2008. There was an update in 2016, but if you go to the Ground Source Heat Pump Association website, there's a thermal pile standard for the UK. I am working, in fact, it's completed, is the International Ground Source Heat Pump Association will be releasing a energy foundation standard along the lines of the Ground Source Heat Pump Association, and that will be released for public comment imminently, I'm told. I think all the kind of geothermal solutions that I showed on the slide, every standard is being updated, so we're waiting for every other standard, so they're going to issue everything in one big go. And I think there was a German standard, VP, I can't remember the number, VEI. But yeah, so there's some good working practice guidelines that you can follow, and I'm hoping I will be working on a DFI standard too.
Yeah. One of the you've both have been saying is that there's lots of opportunities. This technology is nothing new. This has been around, or the concept has been around for a long time. And yet it is still not being applied all that often. And let's put it very mildly. You could say that in lots of places, still an exception is being applied. From both of your perspectives, what can an engineer, because the people that are on this webinar are obviously interested in this topic, they might want to suggest it to an owner that this needs to be done. What is the crucial message that an engineer should take to the owner to really make this happen for a permanent scenario, or even for a temporary retaining wall that Hursit was talking about. Can you give some guidance here? Let's start with you, Tony.
I'm interested to know what Hursit was going to say, but so the important thing here is to be talking to the kind of being involved in a project as early as possible.
Yeah, that's correct.
And you know, when a job comes out for bid, for RFP, it's too late. You know, the architects and the developer have already kind of shaped what they want to build, and it's almost impossible to change at that point. So when I was at Skanska, Cementation Skanska, in the 2003-04 era, we would very often get asked for early contractor involvement, which was great. That enabled us to help shape a solution. And so one of the things that we would always say was, look, you know, you've got great deep structural elements here. What about a geothermal? And we kind of joined up with the Geothermal International in the UK, which is kind of where I ended up, because I just thought this was such a great solution. The problem with the foundation side of it, you need to look at the complete solution. So it's geotechnical meets mechanical. So you need to have both skills, a geomechanical knowledge. So it's not just about designing. Yeah, we can put geothermal loops in it, but you need somebody that can then say, okay, yeah, this is what heating and cooling we can get from it. But for me, it's all about being involved in the process early.
Okay.
I agree with Tony fully. The earlier, the better, and it's a little bit. It could be done also later, but it's not that good. It's not that optimal for the geotechnical, the geothermal activation. Then, yeah, it's same what Tony said. I agree. It's better from the beginning to be involved. Yeah.
Well, let me give you an argument, and it was also one of the questions that was brought up that an owner could put forward. Is that, listen, I'm going to invest in all this money because it's still going to cost money to put these loops in there, put all the equipment on there, only to find out that the loops are failing, or that it's broken, or after 2 years I come back that it's no longer working, and then I have all this investment, and what am I going to do with it? What would be your reaction to that? And let's start with you. Or is it is it an issue?
No, not really. We by doing this kind of jobs, we tested loops in the construction phase already, and immediately after, and if there is a certain quality assurance to doing this, we do not meet any problems in the past for this job sites what we have done here in Europe, and with geothermal activation, no problem in this case. Yeah.
Okay. Anything that you would like to add, Tony?
I think again, it's important to design the solution so that you have that ability to isolate. So again, the Greenwich project I showed where we had 3 loops in each pile, but those piles were run back to a submanifold. And if there is an issue with one pile, we can isolate that one pile. What we don't want to be doing is linking multiple piles together in a series. It's a bit like that electrical thing we used to do at school, where you know you've got your parallel and your continuous flow of electricity. If one light bulb goes out, everything goes out. Whereas if you create these parallel circuits, you've got sort of multiple redundancy. So it's important that you look at that as okay, how many loops can I lose on this project and still maintain the system? And what you'll find is that you know you can lose quite a few loops. It's just that the temperature changes quite a bit. But for me, it's all about getting the QA/QC right and making sure you know the foundation contractor is fully aware. It's plastic pipe. And I've got a photograph of a guy cutting steel. We put some timber boxes over the geothermal loops where they came out the side of the pile caps on the Google project, and the guy was cutting with a steel grinder, and all the kind of sparks were going on the loops. And I tapped on the shoulder. And I said, "What, you know?" And they kind of, oh, well, yeah, sorry. So it's, toolbox talks and making sure, everybody on site knows that you can't drive over this this kind of material. There is a little bit of extra care needed, but again, the coordination between all parties, if you get that right, most cases have had 100% success rate. On that Google project, we did 3,000 plus piles, and I think there was only 2 or 3 that didn't work at the end, and there was enough there that that we just added. I mean, there were so many piles that there was added redundancy in that number anyway, so it was good.
One of the issues, of course, that are often brought up as well, that where failure could occur over time, is because of the temperature differential. You put fluid in the loops that have a different temperature than the piling material. Therefore, you have with expansion and contraction differences there. Is there a problem there that things could start going wrong and start breaking, or is it something that people don't need to worry about?
I think it's
Yeah.
Go for it, Hursit.
It's in my opinion, there's no issue because the temperature range is limited to a certain range, and this range, the interaction is foreseeable, and it doesn't harm over time the bond between the pile or the construction member and the soil. Yeah, it's my opinion. Yeah.
I think, and there are quite a few papers that I've been party to and been involved with Cambridge University, and I think the important thing is to make sure the loops don't go below freezing. So you can put a control strategy in that restricts it, but what is important is that long-term monitoring to make sure that the ground temperature, when mechanical engineers do an energy model, there's so many different sort of, they have to work out what U values am I going to use for the windows, what's the wall to window ratio, what insulation, what's the heat, and it's a really subjective model. I mean, we could all have a go at creating a heating and cooling load for a building, and we'd all come up with different answers. And it is about, well, what is the true energy model at the end of the day? Designing a system that, with the air source heat pump, ground source heat pumps, we have the ability, and importantly, climate change is becoming an issue, as we know. But what we're seeing is an increasing air temperature, and we did Oxford University. We did multiple projects there, and they would ask us. We had to design on a 20-year worst case rising temperature scenario, because as the temperature is rising, your cooling temperature is going to cooling requirements are going to increase, which means more cooling is going into the ground. So it's making sure that the ground and what the amount of geothermal loop in the system can cope with that, or you have a top-up air source heat pump, dry air cooler, that kind of thing, that can then help deliver and maintain your ground temperature over time. You don't want that gradient. You want a nice, reasonably level temperature profile of the ground. In the US, it's about 55 degrees Fahrenheit. Here in New York, that we want to keep it at that year on year. And okay, we're going to make those changes as I've suggested and treat the ground like a battery. But it's, we can make that ground a lot more efficient by making sure that we can keep within those set boundaries.
When you're talking about using the ground or the soil as a battery, in saturated soils, is it not very hard to achieve when you have some groundwater flow as well? Because then obviously the higher temperature that you put in there is being taken away by the groundwater.
Yep, absolutely. So a conductivity test will determine whether the suitability of the ground. And interestingly, on that 561 Greenwich project, we're quite close to the River Hudson, and we were expecting to see much bigger temperature shift. What we found was a much higher ground temperature than we anticipated, but very little impact from the tidal change there. But it is an important fact. If you eat sands and gravels and you've got more sort of flowing through that material, then yes, it's going to change. And yes, you're absolutely right. You wouldn't be able to treat the ground like a battery. So you design your geothermal system differently for that.
Okay. Last question, kind of philosophical question. Say that we're here 5 years from now, and we have a similar webinar, and I remind you that you were here 5 years ago, and you gave your presentation. At that time, you were still somewhat not so positive that people were really applying it all the way through.
Frustrated.
Frustrated? Well, whatever you... do you see major changes? Do you see... Is there a tendency right now that, okay, it's still frustrating, but at least there's an uptick and it's an exponential uptick, so things are really changing? Or do we say, based on what we see right now, the chance that we're going to have a major change in the next 5 years is going to be limited? And Hursit, starting with you, how do you see that? Do you really see a major uptick coming? Or do you say, well, it's still going to be, as Tony says, frustrating in the next couple of years? It's going to be a fight.
Yeah, it depends on the interest rate a little bit. So for in the industry, of course, but my expectations that it becomes more and more interesting for all investors also to include the geothermal activation for our geotechnical works here in Europe, especially. In US, I cannot say this. Maybe you know more than me, but in Europe, I expect in 5 years an accelerating development here for such demand. Yeah.
Okay, Tony.
Depends who's going to win the election in November, Gerald.
Okay.
But I mean, yes, we've seen a massive change here in New York. I mean, I was based in Chicago and spent more time flying backwards and forwards from New York. You know, the NYSERDA, the New York State Energy Research Development Agency here, have been funding feasibilities for ground source solutions, district energy type solutions. It's happening here in New York City in a big way. That said, and then on top of that, we've got the Inflation Reduction Act, the tax credit, which for ground source heat pumps is phenomenal. But we're still seeing mechanical engineers designing systems as if it's a gas-fired boiler and a rooftop chiller. Okay, what's the peak load? And then times it by 3. You can't design a geothermal system in that way. You need to know what's happening every single hour of the day. And yeah, there's still a long way to go. You know, and it is frustrating. And I would say that once you get involved in a project, you've got 2 or 3 years before it becomes reality. And it's that timeline. And yeah, I mean, the Inflation Reduction Act is great, but there is a certain level of uncertainty as to whether it will provide you that 30% at the end of the day. In New York City, Con Edison are providing a clean heat incentive. So they will provide $1 million. There's lots of money being thrown at geothermal solutions here. So I'm optimistic, but like I said, it's a frustrating job because, you know, I've spent 18 months thinking we've got a job here. Big district energy solution up in Edge on Hudson with 90 homes would have been perfect. Geothermal loops in all the building foundations. Con Edison, we're going to pump in 1.5 million. And it was like, it was almost going to be free for the developer. And this was in 2021. He was trying to get some money. He went to an investor, and the investor came along at the last 11th hour and said, "I've never heard of geothermal. You can have my money as long as you go gas and not geothermal." And that 18 months of sort of design and discussion was all for naught.
Well, hopefully by having this webinar, more people are familiar with geothermal. see the options there. And I also would encourage people that are attending this webinar, if you're interested in this topic, join the Sustainability Committee, join the work group that Tony leads on geothermal energy within DFI, because then by disseminating this information, by sharing case studies, by sharing information, by sharing advantages, it will only get a lot better. I want to thank both Tony and Hursit for the contribution today. Thank you for your presentation. Thank you for putting this thing together. And also want to thank the attendees for participating, because obviously we don't do this necessarily to sit behind this computer screen and talk into this big cloud and hopefully that somebody will listen. The fact that you were here in large numbers is very helpful and hopefully allows us to spread the news. If you did officially sign up, there are two options. You can have attended this webinar for free, but if you signed up to get your PDHs, the certificates will come very quickly. And obviously, this is not the only webinar that DFI put forward. I have to give a shout out to the It's Money webinars that we do once a quarter these days. The next one will be in the first Wednesday in June, simply because I'm the moderator of that. So a little bit of publicity for increased testing saves money. But there are plenty of other webinars that different committees put up, and I would suggest that you go to the website. You see there the DFI website for other webinars that come up. And more importantly, again, we don't do these webinars for us. It's there for the membership of DFI. It's for the industry. So if there are certain topics that you want to hear about, let us know. I think it was Hursit who put in his presentation that that it was a webinar about a carbon calculator. The reason that we did this was people are starting asking questions. What is it and how does it work? And that's why with Kimberly Martin some time ago, I did this webinar about a carbon calculator. And there's another one that deals with the use of the carbon calculator specifically for consultants that Katie Costello put together last year. So plenty of webinars, but in a way, in response to suggestions from you. So please feel free to contact DFI, to contact myself if you have other suggestions. And if you have any specific questions, you see there an email address as well, technicalactivities@dfi.org. That is a good email address to use. With that, thank you very much for being here, and hopefully see you again at another webinar. Thank you very much.